Today we will see the solution for problem 7.5 of chapter 7 of Griffith, the third edition. Already we have seen the part of this problem, that is section A. Today we are going to see the part 2, which is related to harmonic oscillator perturbation. Previous case, that is infinite square well perturbation, that is section A. Section B is related to harmonic oscillator. So we will see the solution using harmonic oscillator operator and solve this problem. In section B, we have to calculate the second order correction to ground state energy E0 potential as given in problem 7.2. I have already solved the problem 7.2 in my earlier lecture. This is related to the harmonic oscillator. First one is related to infinite square well potential. This is related to harmonic oscillator. In problem 7.2, it was given that perturbed potential is of epsilon naught k x squared. Sorry, not epsilon naught, epsilon k x squared. And check that your result is consistent with the exact result. That is our question. So here epsilon is very small, and the x squared, the position k is the uh, that is equal to m omega squared. We will see the solution in detail. This is our second part of the problem. That is, the perturbed Hamiltonian is equal to epsilon of kx squared. First task is we have to find this inner product psi m h prime psi n, which is equal to h prime is I am replacing h prime by 1 over 2 epsilon k. Psi m x squared psi n. Here, since it's a harmonic oscillator problem, we can use this harmonic oscillator operator, annihilation operator, and creation operator. I have given in detail about annihilation creation operator and solved the problem 2.12 of Griffith. Kindly refer my lecture for detail about the annihilation and the creation operator. The X position operator in terms of this annihilation creation operator is equal to square root of h cross divided by 2m omega a plus a dagger. A dagger is creation operator, a is annihilation operator. So in this example, we have to find the expectation value of this one. So this expectation value is this x squared will become h cross divided by 2m omega. Since it's a constant, I am taking out of the inner product. Then this is the operator a plus a dagger whole squared. Because this is x operator, x squared is you have to square this one. If you square this one, you will get h cross over 2m omega, and you have to square the operator also. Uh, and now you bring this to the left hand side in order to have a convenience, mathematical convenience. So this will become 2m omega over h cross expectation value of x squared, which is equal to bra m. If you square it, you will get a squared plus b squared plus not 2ab, because a and a dagger will not commute. So you have to write as a dagger, a dagger, a. So this is the expectation value of x squared. Now you separate this into four parts. One with a squared, and another with a dagger, another with operator a dagger a, and another with the operator A dagger square. Now we got this expression. First take the second inner product. If you operate on creation operator over this get n, it will raises its energy level by one state. You don't now you don't worry uh, about the expansion coefficient. Anyway, this is going to be zero. I will explain why. So, if creation operator act on n, you will get n plus 1. And then you can take the square root of n plus 1, which is expansion coefficient outside the inner product. Then here you will have n plus 1. If n plus 1 act on the annihilation operator, it reduces the state by 1. So it's again n plus 1 will become just n with the expansion coefficient. So now it is the inner product between m and n. We know m and n is not equal in our case. So this will become 0. Similarly, here you come here, when annihilation operator act on n, it reduces the state by 1. That is, n will become n minus 1. If creation operator act on the same, then this n minus 1 will become n minus 1 plus 1 because it raises the state by 1. So this will become n. So this is the inner product of m with n. M and n are not equal, so naturally this will also 0. Now we have to worry only about the first term and the last term. You take first two term. Now this uh, a squared can be written as a multiplied with a. If annihilation operator act on this n, it will reduces the energy state by 1. It will become n minus 1 with expansion coefficient square root of n. So that is the case. Here one more operator. We have to operate once more. Similarly here, when creation operator act on this, uh, it increases the energy level by 1. So n will become n plus 1 and coefficient square root of n plus 1. Now, if a again act on this n minus 1, it will reduce further as n minus 2 reduces by 1, and this coefficient is square root of n minus 1. Similarly here, when a dagger act again on the n plus 1, it will further increase its energy level by 1. So n plus 1 will become n plus 2. So with the coefficient square root of n plus 2. So now you bring this multiplication factor to the right hand side, so it will become h cross over 2m omega. uh, this one here I am bringing this n inside the square root, so this will become square root of n into n minus 1. This is 1 only when n minus 2 is equal to m. So delta m n minus 2. So this is the Kronecker delta, and here you come. You bring both the term inside the square root. So this will become n plus 1 into n plus 2. Then uh, delta m n plus 2. This will be 1 only if m is equal to n plus 2. Is understood because it's a inner product. Due to orthonormal property, you will get like this. So now we got this one. Now we got this expression for expectation value of x squared. That is psi m h prime psi n is equal to half epsilon k psi m 0 x squared psi n 0. So x squared, this is a expectation value. So just you replace this by this one. So then this inner product will be replaced by this term. Of course, we have half epsilon k square. Here k is equal to m omega square. So I have replaced k by m omega square, and here you have 2 and here you have 2. 2 into 2 you will get 4. So this is the 4. So here there is m omega and here m omega squared. So this will get cancelled. You will get only the omega here, omega in the numerator. So this will be epsilon divided by 4 h cross omega and this factor multiplied by this parameter. Okay. Now we got this inner product which is equal to epsilon over 4 h cross omega and this term. Now, in order to find second order energy correction, you take modulus square of this term. Then this will become epsilon squared over 16. 4 squared is 16 and h cross omega squared, and this entire term inside the bracket is square. And in the denominator, you can see is ground state energy, nth state, n0 and m0. n0 is equal to n plus half h cross omega minus m plus half h cross omega. This is em. First term is en, second one is em. Now you can replace the numerator by this value, the square, including this constant. So this will become epsilon naught epsilon square divided by 16, and this h cross omega, how we got it? Here you have h cross omega. Just I have changed the numerator by this term, and this h cross omega squared will get cancelled this. Here you have h cross omega, here h cross omega, which will cancel with the square. So naturally this will be the constant is epsilon squared over 16 h cross omega summation over even n is not equal to m, this one. This term I have taken n into square root of n into n plus 1 delta m comma n minus 2. Similarly, this is square root of n n plus 1 n plus 2 delta m comma n plus 2 whole square divided by n minus m. Now we got this expression. Uh, Here one important point is uh, we have to square it. Uh, but see the Kronecker delta condition. Here delta m n minus 2. Here it is m must be equal to n plus 2. So both are independent. So I am taking a square uh, square of this one, that is n into n minus 1, this Kronecker delta, and this is n plus 1 into n plus 2, this Kronecker delta. Because the delta conditions is different for both, so we are taking the individual square. That is cross term is will go away naturally. So we have taken individual square of this thing. So here I am separating this into two parts. One is the first term of the numerator and divided by this denominator, and I have taken the second term of the numerator as it is and the denominator. So now you see in the first term, the condition is m must be equal to n minus 2. So under that summation only allowed. So you can remove the summation term. Only under this condition, when m equal to n minus 2, it is 1. Otherwise, it will be 0. Here I am replacing m by n minus 2. This m by n minus 2. Similarly, I am replacing this m uh, by n plus 2. So naturally, the summation will go away because we have used the delta function property. So the second order energy correction is E squared divided by 16 H cross omega and this term. We will further simplify it. First, we will simplify the denominator. In the first term denominator, n minus 2. So this n will get cancelled. Minus of minus will become plus. So this will be in 2 in the here, this n will cancel with this n, and this will become minus 2. So I am bringing this minus here. So naturally, this here also denominator is 2. So I am taking the denominator as a common one. So this will be like this. Just you multiply. This is n squared minus n. Here, n squared. 2n minus 2n. Remember that here is a minus. So minus 2n. Then 1 into n here minus. So that will become minus n. And minus 1 into 2 minus 2. So here you can simplify this plus n squared we cancel with this minus n squared. Here you have minus n minus 2n minus n. So 4n minus 4n minus 2 minus you take out. So this will become inside the bracket 4n plus 2 divided by 2. So you will get second order energy correction is En2 is equal to minus epsilon squared divided by 16 H cross omega 4n plus 2 divided by 2. So the second order correction we got this one. Here you can see 4n plus 2. You can take 2 and if you 2 by 16 will become 1 by 8. So if you take 2, 2 will cancel with the 16, 16 will become 8. This will become 2n plus 1 because we have taken 2 outside. So this will be divided by 2. This can be rewritten as minus epsilon squared over 8. Uh, this will become, if you divide this by 2n by 2, you will get n, and 1 by 2 of n plus of course, this h cross omega you will get. Which agrees with the epsilon squared term in the exact solution. We have found the exact solution in problem 7.2a, in which we found that the energy correction is n plus of h cross omega. We have calculated first three term plus 1 over 2 epsilon minus 1 over 8 epsilon squared. If you coincide the epsilon squared, because here we are doing second order correction, you can see here it is minus 1 by 8 epsilon squared minus epsilon squared by 8. Of course, this n plus of h cross omega will come like this. So this is exactly matching with the solution, exact solution of problem 7.2a. Thank you very much for watching my videos and supporting me continuously.